this is Miguel speaking. I'm presenting my lesson 3 homework with a twist. Instead of 4 LEDs, I'm using 14. That's because I wanted to use this same circuit for lesson 4 homework. As you can see, I'm using regular Raspberry Pi Pico with no Wi-Fi, and all my LEDs are connected to its own current limiting resistor. I'm using pins from GP12, that will be physical pin 16, through GP28, that will be physical pin 34, I think. Let me check in the diagram, the pinout diagram of this microcontroller, and you can see that GP12 is pin 16 and it goes through GP28, that is physical pin 34. Okay, let's return to this. Okay, jumper wires are kind of messy, but I managed to make it look neat. Well, I think it's okay, but let's check the code. The code is only 15 lines. It's pretty short. I decided to use a lambda function to avoid creating everything and save it into a variable. So what I'm doing is getting an array from this line. Let me explain it. A lambda function is an anonymous inline function. I create this one that takes only one argument, and it returns the pin, the output pin, with the argument as the first parameter of the response. This will be executed for every one of these numbers that correspond to the GPIO pins of the Raspberry Pi. You can see here the physical number of the pin. The physical number of the pin is the one I'm using for the list. And using the map function, takes 2 parameters. In this case, the first one is a function, and the second one is an iterable. This function will be executed for every one of these elements. So it will return pin 16 pin out, pin 17 pin out, and it will go to all the values. Those will be saved as a list in my LEDs variable. Now I have a try except block that captures keyboard interruptions. Just do not print these red lines, this error on the shell of the program. I print this message, see you later RPI Pico, and turn off all the LEDs. This is a short form of a loop, and it is going from every element in the list and running this function on every element. So it is turning off every one of the LEDs inside the LEDs list. The important code is wrapped around a while loop. Remember that a requirement for the homework was to, when reaching the max value of the loop, start again. So this is the way I can do that. Inside the while loop I have two for loops. The first one goes from 0 to max iteration -1, that will be 16,383, because between 0 and that value I mentioned are this number of iterations. That is the maximum value I can represent using 14 bits. That's why I'm using it. In the second for loop, you can see that I'm using this function called enumerate that returns an enumeration. An enumeration contains the element inside the list in the current position with its index. And I'm using this one to make a calculation that returns me the value I will use to toggle the LED. For every iteration of the outer loop, I'm stopping this for 0.001 seconds. That have to be really fast because I have 14 LEDs, and let's see if I use a second to delay these iterations, it will take 4 hours and a half to finish one loop. All that will be while this condition that says that if current iteration is less than the max value I could reach, that is this 1 minus 1, it will be using this value. If not, that will be the max value I could reach. It will delay it for a second, and that will be keeping all the LEDs on for a second to show the user that, or to only show that the iteration reached its max value and is about to restart. Okay, this operation I break it in three examples to explain it. Okay, this will be a representation of the inner loop, this one, and I'm using it to show the values that every one of the bits in every LED represents, like Paul explained in his lesson 3 when he mentioned this, that for 4 bits the maximum value you can have is 15. So that is because when you sum those values, 8 plus 4 that is 12, plus 4 that is 14, plus 1 that is 15, that is the max value you can hold in a 4-bit number. Of course, in my case, it will be a pretty big value because I'm using 14 LEDs. Let's sum all the values to check that. So I have this one, 40,096, 2048, 1024, 512, 256, 128, 64, 32, 16, 8, 4, 2, 1, and that's it. 16,383. That is the max value I can reach here in this variable. Okay, now I'm going through 16 because I in 4 bits, because I'm using 4 bits for this example, I can only represent that for the value of 15 for 4 bits, and I'm using 15 because these are many LEDs. I cannot use the full quantity of LEDs because it will take a lot of time. Here you can see that for each iteration of the outer loop, the inner loop runs a full loop and is going through all the 14 LEDs. In the first one, when the value is 0, you can see the value is 0. Then in the second one, the value is 1, but this is not the values I'm writing to the LEDs. These are the values I get that will allow me to make another calculation through modulo operator and get the 1 or 0s that I will use. So right now at this moment it does not make much sense, but it will be it will make sense at this explanation. Let me run it. How you can see, at the first one all of the numbers are 0, at the second one 1. Well, the second one, that is the number 1, this one will be, this LED will be on, oh sorry, this one, the first one from right to left will be on, and all through the end. Remember that I'm using 15 values, so it will iterate 15 times. And here is what I will finish having with these the four LEDs on, or the value representing what I'm using to toggle the LEDs. Okay, let's see this in action. Oh no. Okay. Oh, we'll delete that this way. Okay, let's run it. And I have an error. Okay, let's check. Indentation doesn't match. Oh, where will that be? This is okay, this is okay. Okay, line 15. In line 15, oh, I can see now. Okay, let's run it. As you can see, wow, the first one is turned off. You will see a transition between these LEDs when they are turned on or off, because I'm running a for loop with an interruption to show that how many times it runs for every iteration of the other loop. Here you can see the number of the current iteration and its corresponding value being printed here. So you can see when a LED is turned on, and then when a LED is turned off. This can't happen during the execution of the homework because it will be confusing. I'm going to, well, it's about to finish, and there it is. And now I'm going to comment this line to avoid interrupting it during every iteration of the inner loop, to show you how it's working. You won't notice that this transition I mentioned before. See? Pretty nice. Now let's run the homework. You will see that it's really fast because I'm using a pretty short interruption time. I'm going to interrupt this to show that all LEDs are turned off thanks to this for loop, this sentence, and print this value, this text to the console. See you later, RPI Pico. Now let's run it till the end. You probably won't notice that this LED is blinking, but if you pay attention, you'll see that it is kind of blinking like a flame, because it is being turned on or off, almost like power with modulation. I'm not using it here, of course. And when these LEDs reach the maximum value, they will be on for a second before starting the next loop. And we will see that pretty soon. There you go. There is it. Well, thank you for watching, and see you later.